Hi gang, today we're going to continue looking at some more complex sequences. Sometimes a recursive formula is more than just adding the common difference or multiplying by the common ratio. Keep in mind that a recursive formula tells us what to do to the previous term to get the next term. So we're going to generate the first 5 terms in each of the sequences below. So taking a look at this first one, they tell us that the first term is -8. So I'm going to set up a little table where I have n and a of n, and I know the first term is -8. So now I have to take the previous term, -8, and replace it with a of n minus 1 in the equation to get the second term. So I'm going to do 2 times -8 plus 5, which is -16 plus 5, which hopefully you know is -11. So that makes the second term -11. Now to get the third term, I take the -11 and replace it into the a of n minus 1. So now I do 2 times -11 plus 5, which is -22 plus 5, which hopefully you know is -17. Now to get the fourth term, I do the same. So now I have 2 times -17 plus 5, which is -34 plus 5, which is -29. And then I do it one more time to find the fifth term. So 2 times -29 plus 5 gives me -58 plus 5, which equals -53. And so I've used that recursive formula to generate the first 5 terms of the sequence. All right, so similarly, we have number 2, a of n equals 4 times a of n minus 1 minus 3, where the first term is 15. So again, I have n and I have a of n. First term is 15. So to find the second term, I replace 15 with all of a of n minus 1. So we have 4 times 15 minus 3, which is 45 minus 3, which is 42. So the second term is 42. And then I replace the a of n minus 1 with 42. So 4 times 42 minus 3 is 168 minus 3, or 165. So the third term is 165. To get the fourth term, I put the 165 in for a of n minus 1. So that's 4 times 165 minus 3. So I'm going to use the calculator real quick so I don't make a silly mental mistake. 165 times 4 is 660. These can grow rather quickly. Minus 3 makes 657 rather. So then to find the last term, the fifth term of our sequence, not necessarily the last term, but the last that we have to actually find, we plug in that 657. So 4 times 657 minus 3 is that 2,628 minus 3 is 2,625. And again, we've generated the first 5 terms of the sequence given. Okay, so let's see if we can try some more challenging ones before you're on your own. Number 3, now I have to do some things in parentheses first. Remember, with your order of operations, parentheses always comes first. So again, they tell us the first term is 3. So we plug the 3 in for a of n minus 1. So we're going to do 2 times 3 plus 1, which is 2 times 4, so that's 8. So the second term is 8. To find the third term, we're going to plug the 8 in for the a of n minus 1. So that's 2 times 8 plus 1, which is 2 times 9, or 18. To get the fourth term, we plug the 18 in. So that's 2 times 18 plus 1, or 2 times 19, which is 38. To get the fifth term, we plug the 38 in. So that's 2 times 38 plus 1, which is 2 times 39, or 78. And we've generated the first 5 terms. So number 4 is similar to that because I have parentheses again. So again, we have n and a of n. And the first term is given as 35. So we plug 35 in for a of n minus 1. We're going to do 1/2 of 35 plus 1 is 1/2 of 36, so that's 18, making the second term 18. Then to find the third term, we plug in the 18, so that's half of 18 plus 1, which is half of 19. So that's going to be 9.5. To get the fourth term, we do half of 9.5 plus 1, which is half of 10.5. So that's 5 1/4. And to get the fifth term, we do half of 5 1/4 plus 1, which is 6 1/4. So half of 6 1/4 is 3.125. And I'm just checking my work. I'm pretty sure I'm right, but I am correct there. So again, to find or use a recursive formula, you're continuously plugging in the previous term to get the next term, and on and on and on and on until you get to the desired term. All right, so hopefully you're picking that up easily. This is a concept that most kids usually get right away, but forget about it later. So we have to make sure that we're consistently coming back to this so you don't forget it by the time we get to the Regents exam. So you are now going to try numbers 5 through 14 on your own. Make sure you're checking in with me so I can be sure you've got it before moving on to the exit ticket.